Welcome back to the Harsh Reality of School. Multi-step problems. Multi-step problems. Multi-step problems. If you had to guess what multi-step problems are, you would probably guess that they are problems with multi-steps. How about that? Problems with more than one steps. One step. Now you can't really explain this until you have an example in front of you. So let me shoot you out an example of the problem here. Example here, what is the difference between the product of 6 and 4 and the sum of 6 and 4? The product of 6 and 4 and the sum, that was again, of 6 and 4. Give you a chance to jot all that down there. Got it jotted? Got it jotted? Here is the deal with that, ladies and gentlemen, and I need to see this on your paper. First of all, the problem with story problems is there's a lot of words, and sometimes we have a difficult problem connecting words in math because it's like English and math and they're not really the same thing. Alright, so you have to break it apart and you have to show your work on this. Okay? And as you look at this, this is what I should see on your paper. The first thing it says, what is the difference? Well, in math, there are 4 different things you can do. We call them the mathematical operations. And in math, really, there's only 4 things you can do. You can add, you can subtract, you see where I'm going with this, you can multiply, or you can divide. That's really all we ever do in math, technically, one sort of way there. So the first thing this says is what is the difference? And difference, hopefully you know, well, let's jot them down in case we don't know. The answer to an addition problem is called the sum. The answer to a subtraction problem is called the difference. The answer to a multiplication problem is the product. And the answer to a division problem is called the quotient. Okay? So when you see those words pop up, that's what you should be thinking. So the first word we come to, it says, what's the difference? So you're trying to find the difference, which means there's going to be subtraction in that problem. So you put down a little subtraction sign. And then you have to answer this question, what am I subtracting? Well, that's what the rest of the problem is for. You are subtracting the product of 6 and 4. Well, product means you are multiplying 6 and 4, and it's probably good to put that in parentheses just to make sure, because we want that product to be done for it. We want to know, there's my product of 6 and 4, and I'm subtracting from that, let's change to a bizarro color, the sum of 6 and 4. And you know that sum means adding 6 and 4. This, ladies and gentlemen, is the first step in what I should see on your paper. I don't want you just to do all this in your head. Show me what you're thinking. And then I can actually do the problem. The product of 6 and 4 is 24. The sum of 6 and 4 is 10. And 24 minus 10 is 14. That will be the answer to what is the difference between the product of 6 and 4 and the sum of 6 and 4. You really, I mean, there's just a lot of words there that can confuse you. You just need to break it apart piece by piece, jot it down, and then hopefully it becomes a little more clear to you, Victoria.
Do you have to like write the parentheses?
No.
Like, can you just write like 6 times 4?
No, I would like to see these parentheses. Because when it says to find the difference of the product, that means you got to find the product before you work the difference.
Then could you just like
Because if you did not put this in parentheses, technically in math, you should have taken 24 minus 6 and then added 4 to it, which would give you a different answer. So they're telling you to find the difference between a product and a sum. That sum should be in parentheses to tell you that you need to do that before you do the whole difference thing there. So really you should do that there. Let's look at another one. So I can tell you're very excited about this. So much excited.
Yay!
How about this one? When the product of 6 and 4 is divided by the difference of 6 and 4, what is the quotient? When the product of 6 and 4 is divided by the difference, is that what I said? Difference of 6 and 4. What's the quotient? And the product of 6 and 4 is divided by the difference of 6 and 4. What's the quotient? Got that written down? You're fast writers. Now you have to be a little careful in this one because the book obviously messed with you a little bit and that they kind of put things in a little bit different order. What type of global problem is this? And by that I mean this. When I went back to this one here, what is the difference? This whole thing overall was a subtraction problem because I was looking for the difference in those two things. What type of problem is that one? Please note, it's not just the first word you run to. Maybe the first words you see in there. Tyler?
Multiplication and division.
Well, you have to pick one or the other. It can't be both. Now, I will tell you that, okay, you can take this whole phrase right here and put it at the beginning of the sentence and say, what is the difference, or what is the quotient when the product of 6 and 4? That's kind of what that means there. So, Tyler, you said division, and I will completely agree with you. This overall is a division problem. You are looking finally for what's the quotient. What is the quotient? And what two things am I dividing? Well, the first thing is I'm taking the product, again, put a parenthesis there, of 6 and 4, and I am dividing it by the difference, which is 6 minus 4 of 6 and 4. And again, ladies and gents, this, I would very, 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 very much like to see this written on your paper so that it's clearly evident to all. And then when you do the math, 6 times 4 is 24, and I am dividing that by 6 minus 4, which is 2. And 24 divided by 2 is...
Wait.
Sometimes these take just a little bit of difference, or a little bit of time to figure out what's going on. And then we have one more thing, another blank piece of paper, please. And I don't think have we done place value? Yeah, not this. Because you're 6th graders, you go right to the top right away, and they start you off with numbers that are in the trillions. 7, 8, 6, 4, 3, 2, 9, 5, 1, 0, 8, 7. We put commas in numbers. Why, you ask? Nobody's asking. Because if you didn't, you would find it very, here, 6. If I asked you to read that number for me, you are going to sit there and try to divide it kind of in your head, and it's really easy to get lost in all of that because you can't see where the division parts are. We divide it into groups so that we know each one of these parts. They call them periods, I think. Okay? Like, for example, this one is the units period. This one is the thousands period. This one is the millions. I guess I did need one more. This one is the billions. And that last one there is the trillions. I did miss one. Let's go back to red. What should we put up here? 952. And this one here is the trillions. And we put commas there so you can quickly recognize what grouping or what unit it is, so when you say it, you can say that. For example, when I'm reading this number here, because of those commas there, it's pretty easy to do. You say 952 trillion, 786 billion, 432 million, 951 thousand 87. And without those commas, let me read that number for me. Did somebody get there yet? It's a little tough to do without the commas, but once you put the commas in there, it kind of magically appears. You've got this, you've got the thousands, the millions, you've got the billions. It's 6,349,800. I'm sorry, 6,349,853,262. Without the commas, you kind of get lost in the shuffle of all that. And it's important to know that it's, every one of these little errors or commas or periods here, this is the hundreds, this is the tens, this is the ones. So 951 or 432. This is the billions, trillions. Did I ever show you the how much is a billion or how much is a trillion video?
No.
You sure?
Yes.
Let's look and see if I can find it. It puts things into perspective. We have absolutely no idea how big a billion is. I think it's a billion, or maybe it's a trillion.
This is 1 million.
I don't know what it is. I can't remember. Somewhere they should say how much is a billion. Is it there? It looks like a slideshow. You see it anywhere? Maybe it's not 6th grade. I show it. Maybe it's just in math. Let's try it here. Maybe it's down at the bottom here. Any of you see how much is a billion? Look. Too fast. Maybe it's under, what would it be under? Samsung? Let's try one more. Maybe it's down here somewhere. What's a trillion? There it is. You sure I didn't do this before for you?
No.
What a great way. Okay. How much is a trillion? Think about this. If you've ever wondered what a trillion is, what kind of things do you know that come in trillions? Well, our debt is a trillion. This comes back from kind of government thing here, but here are things, and the government talks about how much we owe other people. It gets in the trillion there. $1 trillion. What does that look like? I mean, these various numbers are so tossed around like so many doggy treats. I thought I'd take Google SketchUp, blah, blah, blah. Here we go. Forward. We'll start with a $100 bill. Pretty much the biggest bill you're going to see somebody's going to give you. They're not going to give you 1,000. Penny saved. How many of you have ever touched one, had one? How many of you own one? You probably own one. You have $100, right? That's $100, not what it used to be, but it's still a lot of money, right? You'd probably bend over to pick up a $100 bill. All right. So if you take $100 bills and make $10,000, okay, that's 100 of them stacked on top of each other. It's a half-inch thick. If you had 100 $100 bills, how many have they ever seen 100 $100 bills in the stack? In the movie, yeah. That's 10,000. That's right there is $10,000. Again, that's a pretty serious stack of cash. All right. So this would be if you took that same little packet. Sweet. If you took 100 of those packets and stacked them up, right there is $1 million in $100 bills. See how tall the guy is compared to the little stack down there? That's actual real life. Okay, you'd have, what, 10 rows of 10 or whatever it is. Or you could stuff that into a grocery bag. You could put $1 million in a grocery bag and walk around with it. Yeah? All right. If you took and wanted $100 million, that's about the size. You see the little pallets? I don't know where you see pallets at. Whatever there. It's a little cube about this tall, this wide. That is, what's it say? 100. That is $100 million. 100 million. Remember, we're going to get to a trillion. This is what a trillion is. This is only $100 million. All right. This is $1 billion. It's that same pallet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those pallets is $1 billion. You could probably put 10 pallets in my room. It'd probably go out to, I don't know, maybe Maggie or whatever, up to the front wall. 10 of those pallets. So remember, each one of these is a $100 bill. Each one of those stacks is $10,000. Okay. Now that is $1 billion. Right. Here comes the 1 trillion. Now we'll look at $1 trillion. That's the number you hear about. What is $1 trillion? $1 trillion is a million millions. 1,000 billion. It's 1 followed by 12 zeros, and this is what it would look like with pallets. If you put $100 bills and stacks of 10,000s on pallets, this is $1 trillion.
It's as big as a field.
See the guy? It's stacked too high.
Amazing.
All the way through there. Really, it would be. It almost looks like a soccer field stacked 2 pallets high of $100 bills.
I mean, you could drop that over my house. Where is that guy?
Think about that. How many $1 bills? What would that look like with $1 bills?
What about pennies?
Or pennies? I don't know if it goes any farther than here. Oh. At the rate, well, see how old this is? It said by 2012 we'll be out of trees because we couldn't. Presenting the all-new $1 trillion bill. I'm sure it's going to have Barack Obama on it. Yes, Mr. Barack Obama. See your trillion forward, Mr. Your friends.
What?
They're trying to tell you that it's just our debt is so big. If you think about what we owe, that's what we owe. Enough of that. Anyways, wow, that's all. I think it's probably good to go. What time is it? So your lesson assignment for tomorrow is lesson number 12.